All right, so we are going to start with matrices. So we're going to kind of give you some background on what a matrix is, and then a few examples of how to use it to solve a system of equations. So a matrix is a set of numbers arranged in rows and columns. So we say like an array. So as to form what we call a rectangular array, the multiple of a matrix is matrices. So a lot of times we just talk about matrices. We will use a matrix to help us solve systems of equations. This is not the only use for matrices, but the one that applies to us for now. That's supposed to be us, not use. A typo there. So let's say my system of equations was 4x plus 2y equals -3. And then we have x plus 5y equals -4. So the way we express it is like this. This is actually what we call an augmented matrix. But we're not expecting you to know everything about a matrix. We're just trying to give you some ideas. So how we use matrices is these systems of equations. So what we do is we make it x, y constant. So what we do to place this in a matrices is we say, well, we're going to write this as 4, then 2, then -3. We know everything in this first column is an x, and then everything in the second column is y, and then everything in this third column after this line, that's where the augmented matrix comes from. It's basically two matrices together. That is your constant. So your first row is just a representation of equation 1. Your second row is a representation of equation 2. So we got x to the 1, y to the 5th equals -4. So if we omitted variables and replaced the equal sign with this vertical line. So the rows of a matrix is horizontal, just in case you didn't know, and the columns are vertical. This matrix below, we would call it has 2 rows and 3 columns. So we would say, a second here, a matrix with m rows and n columns is said to be of order mn. So this one would be of order 2, 3. 2 rows, 3 matrices. Or sorry, 2 rows, 3 columns. When it's your m and m is equal, then we have what we call a square matrix. So this is just a little bit of terminology. And as we had already said, this first column represents all your x values. This represents all your y's. The third represents our constant term. Each row represents an equation. So the rectangular array of numbers such as this is called a matrix. And like I said, it's called an augmented matrix because it contains not only coefficients, but also their constant terms. If we just stuck to this part here, that's a square matrix that is called your coefficient matrix. So it's just dealing with the coefficients. So what we're going to do is something called Gaussian elimination. When we're going to have another kind of elimination here, but we're going to call it, it's row equivalent operations. So it may seem a little confusing. I just wanted to kind of go through this with you so you see what solving with a matrix is supposed to be like. Then we're going to do Kramer's rule in a separate video. So what we're going to do is we're going to exchange any 2 rows. So we can flip rows and exchange them. We can't do that with columns though. We can multiply each entry in a row by the same non-zero constant. So kind of like when you were doing elimination method, each row is a equation, right? We could take an equation and multiply it by something. We're just going to do it to the row now. We can add a non-zero multiple of one row to another row. Once again, like our elimination method, we're adding equations. So every time we talk about a row, we're talking about a linear equation here. So we can use the operations above on an augmented matrix to solve the system. So we are going to solve this system here, x plus 2y equals -1, and -1 plus y equals 3. For a second, I thought the one didn't work. We are going to do this with the Gaussian elimination method. So one of the first things I need to do is take that system and put it in a matrix. So remember, x's go first. So this has a coefficient of 1 and a coefficient of -1. So in my matrix, I have 1 and then I have -1. Here I have 2, y also has a 1. So 2, 1. Then my constants, -1 and 3. So our goal is to find a row equivalent matrix that's going to look like this down here. We want a 1 here. Yay, we already accomplished that. We want a 1 here. Looks like we accomplished that as well. However, we want a 0 in this spot. So this, we're going to have to try to figure out how to make a 0 and then see what numbers we get for these 3 here. So what we're going to do, like I said, is we really just need to make this matrix look like this version here. So we need to figure out how to get rid of that -1. So one of the things I said I can do was add rows together. So what we can do is add 2 rows to make a new row. So like I said, like elimination, we can add equations to eliminate a variable. We can add rows to make that -1 into a 0. So here, this is my original matrix. What I want to do is add row 1 and 2 to make a new row 2. So what we have is row 1 was 1, 2, -1. And then we have row 2, which was -1, 1, and 3. So if we add those together, even without the variables on them, so we got 1 plus -1, 0. 2 plus 1, 3. -1 plus 3 is 2. So I'm going to end up replacing this whole row here with 0, 3, and 2. So we've accomplished this part. We've got a 0 here now. Now we have another problem. That's not 1 anymore. So we're going to have to deal with that next. So the other thing that we said that we could do is that we could multiply a row by a non-zero constant. So now we need to change that 3 right here. We need to change that to a 1. So we can multiply the second equation. And that should have been a third here by 1/3, or divide by 3. I don't know how that got a 4 there. I must have been fixing something. So what I'm going to do is I'm going to take row 2. And we're just multiplying it by a third. So row 2 was the 0, the 3, the 2. And we're multiplying that by a 2. So of course that's going to give me here 0, not multiply by 2, multiply by a third. I think I was looking ahead at something. Multiply by that third. So 1/3 times 0, 0. 1/3 times 3, 1. 1/3 times 2, well, that just leaves me with 2/3. And what I'm doing is I'm just replacing row 2 with that. So what we can do is we can add rows, and what we add, we can replace a row with. We can multiply a row, and then we can replace that same row with it. So understandably, this can be a little confusing at first. However, if you do get used to this, it can make solving a lot of systems of equations very easy for you, or at least linear systems of equations. But now we know this. I have 2 equations now. If I was to go back and put my variables back in, we have an x plus 2y equals -1. Here, we don't have an x, but we have that y is 2/3. So this one, probably the matrix was a lot of extra work for us, but it's easier to show. We know what y is for that system of equations. I just need to figure out what x is. So here we get 4/3. I think that's where my 4 accidentally came from. Oops, equals -1. So we're going to get x is equal to, so that's going to be -1 minus 4/3. So we can change -1 to -3/3. Again, -7/3. So now we have x and we have y. Like I said right here, we see that the solution to that original system that we had is going to be -7/3 and 2/3. So this system right here we have a solution for. All right, so there was a mistake in the PowerPoint in this one, so I'm doing it all right here. So first thing we need to do is rewrite this as a matrix. Trying to get my tools there to work. So we would have the top one would be 2, 3, then I have our line, -16. The next one would be 5, -10, then the 30. So remember, we want it to look like this. 0 here, 1's here, numbers here. So first thing that we're going to do is probably deal with this 0 first, because if we do the 1's, it's going to make a bunch of it's going to make a bunch of work for us. So we're going to get this to be a 0. So if I took row 1 and I multiply it by 5. Oops. Okay, I'm trying to get a tool to move out of my way here. There we go. We multiply it by 5. Then we add it to row 2, but instead we're going to multiply this by a -2. Because what that's going to do is that this is going to turn to 10. This will be -10. If I add them together, I get a 0 in that spot. So I'm going to use this to replace my row 2. So if I do that, multiply row 1 by 5, I'm going to have 10, 15, and 5 times -16 is going to be -80. If I multiply row 2 by -2, I get -10, 20, and -60. So if I add those together, we get 0 here. Here we would get second. Made a little typo here. Let me fix it. There we go. Yes, so this would be 35, and then this would end up being -140. Okay, and that was plus 35 there. This is going to give me, like I said, I was replacing, get my new tool here, the second row. So now I'm going to get 2, 3, -16 still on top, but the bottom will now be 0, 35, and -140. So now to get those ones, I'm going to take row 1, and I'm just going to divide everything by a half. That's going to be my new row 1. So if I do that, I should end up with 1 here, 3 over 2 here, And then this would end up being a -8. Then we're going to take row 2. We're going to do this all at the same time. And we're going to divide everything by 35, and that's going to be my new row 2. So like I said, I add 2 rows to replace a row, and then I can multiply or divide by something to get those ones. So in this case, those will be 0, 1, -4. So my system is going to be x plus 3/2 y should equal -8. And we have that y will equal -4. That's what the second one tells me. So if I just want x, I'm just going to place in that -4 for my y. That's going to leave me with a -2, -6. Okay, yes, just make sure I got the right number here. And then this is going to end up, after I add 6 to both sides, x is going to be -2. So my solution is -2, -7. You could check it out. I just did already, so that it does work for both of those.